Hello friends, good morning. I welcome you all for today's session. So in today's session we'll be starting with a derivation of Euler's formula for various conditions of buckling. Right, so today we'll be taking up the first case, that is Euler's formula for buckling of columns with both ends hinged or pinned. Right, so in our previous video we have studied that why buckling occurs, in which all cases the buckling is going to be significant, in which all cases the direct compressive stress will be significant, and all those things. Right, so this condition of buckling arises whenever we are making use of a slender column. What is a slender column? A slender column is a column whose lateral dimensions are very less when compared to its length. Right, so in that particular case, if you are going to apply an axial load, then the column is going to bend or it is going to buckle. So using this Euler's formula, what we are trying to find is the minimum load, the minimum compressive load that will cause the buckling when both ends are hinged or pinned. Right, so let us begin with the derivation part. First, let me consider a column. I'll just draw it here. Let me consider a column such that both of its ends are pinned. Right, so let us say this is a column. Let us say both ends are pinned. Right, now let P be the load acting. Let P be the load acting. Right, so the compressive load which is acting, let P be its magnitude. Now because of this compressive load, what is going to happen? Because of this compressive load, this column will buckle. This column will buckle. So I'll show you the final shape. Okay, so due to buckling, because of this applied compressive load, it will bend and the final shape will be like this. Right, so let us say that the initial length of the beam, sorry, not the beam, of the column, let the initial length be L. So let me mark this, the initial length. Let me mark the initial length. Okay, so this initial distance, let this distance be L. Right, so this is the initial length, let this distance be L. So when this is going to buckle, what I'll be considering is I'll be considering a section at a distance of x from the top end. So let me consider a section at a distance of x from the top end. Right, so let us say I have considered a section. So this is section x. Right, so the distance of this section from the top end, so if I just draw a line, so this distance here from the top end is x. Right, so what I have done, I have considered a column. On that column both ends are pinned, so whenever a compressive load is going to act from both the sides, it will be buckling, it will be bending in this fashion. Initial length was L. At a section x from the top end, at a distance x from the top end, I have considered a section xx. Right, now let me start with the derivation part. So bending moment at a section xx, bending moment at the section xx, bending moment at the section xx is given by, right, so if I just denote it by mx, then bending moment is given by, now here I need to mention one more parameter, that is deflection. So this is the deflection at section XX. Right? Beam was initially straight, then it has bent, so the deviation or deflection at this point is Y. So the bending moment is force into perpendicular distance. So this is section XX, force is P, perpendicular distance is Y. So it is P into Y. So it should be negative. Why it should be negative? I'll tell you. If your initial beam is like this, if your initial beam is like this, and after buckling it gains this shape, then such kind of bending we take it as positive, or such kind of buckling we take it as positive. And if this is the initial position of the beam, if this is the initial position of the beam, and if the beam is going to bend like this, we'll take it as negative. So these two things you should always keep in mind. So what kind of thing you find here? It is very similar to the second case. So that is the reason it is P into perpendicular distance is Y. So it is taken as negative. Right? So we know that the deflection equation is given by, okay, now this is something new to you people, because we have not studied deflection in detail, neither it is directly related to your syllabus. So here you need to remember this equation, which is common for all the four cases which I'll be deriving henceforth. So that equation is E into I into d square y by dx square, right, is equal to mx. So this is the deflection equation for the column, and this you need to remember for all the four cases, upcoming cases which I'll be deriving, and it will remain same. It is a universal equation, it is not going to change, right? So now what you observe here, if you take this as equation number 1, if you take this as equation number 2, so if you compare both these things, then what we can write? So comparing equations 1 and 2, equations 1 and 2, we get, so what we get? So on one side it is equal, so the other part should also be equal. So what I'll be getting here is E into I d square y by dx square is equal to minus p into y, right? So since both the sides were equal, LHS, we can say LHS is equal. That is the reason I have also equated the other side. Now, since all of you have studied in mathematics that derivative dy by dx, I can represent it by y dash, d square y by dx square, I can represent it by y double dash. Right? So this you have already learnt in your mathematics. I repeat, अगर it is dy by dx है तो you are going to denote it by y dash, d square y by dx square है तो you are going to denote it by y double dash. This is a part of your previous mathematics as well as your PUC mathematics, right? So this is equal to minus p into y. So what I can say here is e I y double dash, this p into y, you take it onto the right hand side, p into y is equal to 0. Now here what I can do, just to simplify things, what I will be writing here, let beta square is equal to p divided by ei. So in this, what I will be writing here is beta square is equal to p divided by ei. Okay, now let me divide this entire equation. ei y double dash plus py is equal to 0 by e into I. So I'll just write here, divide entire equation by e into I. So what I'll be getting, y double dash plus p into y divided by ei is equal to 0. But what I have assumed, I have already assumed that beta square is equal to p by ei. So what I'll be getting, y double dash plus, putting the value of beta square, it is beta square y is equal to 0. Right? So I got one differential equation. So I need to solve this differential equation. So people who have come through PUC, you already solved such kind of differential equations. Right? People who are from diploma, you have also studied this but not in detail. Right? So you need to concentrate on this, how to solve this. Right? So now such kind of differential equation will be having a solution with two parts, complementary function and particular integral. So the above solution, the solution for above differential equation, above differential equation is given by, so it is given by y is equal to complementary function. So sometimes it is known as CF plus particular integral. It is known as PI. Right? So this is a part of your mathematics. Now here in this particular case, PI becomes 0. I am not dealing much with the mathematical aspect. Right? So since you have already studied it in the mathematics, here after this I'll be directly introducing the complementary function. So let me write the complementary function. So complementary function is given by y is equal to a sine beta x plus b cos beta x. Right? So this is the complementary function or the solution of the differential equation what I have obtained. Now यहाँ पे क्या होगा, a few things you need to remember, right? Because if I just try to show you how this particular thing comes, then I need to go into the mathematics part. I need to give you a 1 or 2 page explanation. Same thing happens in your examination. If you want to write how it comes, then you need to write, keep on writing the explanation, which will not only increase your time but is also reducing your marks, because the more the time you take, your marks will be reduced because you cannot write or attempt more, right? So what I suggest you people is, for these 4 cases there are no major changes. Wherever there is a change I'll be indicating, so you just try to remember things, right? Now, and for one particular thing I'll be explaining in detail, what is differential equation, how to remove the general solution of such a kind of differential equation, right? एक केस लेके मैं आपको बताऊंगा, right? So just to make you understand, right? So that I'll be telling you in a while in the upcoming sessions. So for time being, you need to remember that y is equal to a sine bx plus b cos beta x is the solution for the differential equation which I have obtained, right? So then we are making use of the boundary conditions. We are making use of the boundary conditions. Now what are these boundary conditions? I'll be writing it as BC. BC stands for boundary condition. BC stands for boundary condition, right? Now, so some people also call it as end conditions. Now, first boundary condition is at x is equal to 0, y will also be equal to 0. So I'll show you the main diagram and I just try to convince you with this. So here you can just check out. I can take this as 0. So when x is 0, deflection क्या हो रहा है? This, no doubt this has bent, but when it comes to this particular point, it is coming back to the same point, right? So at this point, the straight beam and the curved beam are joining to each other. So यहाँ पे deflection नहीं है, deflection is not there, so deflection is 0. So when x is 0, y is also 0. And the second boundary condition would be when x is L, जैसे ही आप ऊपर जाओगे, right? Now when the value of x, because this dimension I have taken it as x in this direction, you can just check it here. So when the x value will become L, when the x value will become L, क्या हो रहा है यहाँ पे? What is the value of y? Y is like this. So y will once again be 0. So there are two boundary conditions. When x is equal to L, y will be 0. And when x is equal to 0, y will be 0. Right? I'll be making use of both these in order to find out the constants in my general solution. Okay. Now this is my boundary condition. So this boundary condition, you please put it here in this. So let us say this is, I'll call it as equation 3. So therefore equation 3 becomes x is 0, y is 0. So y is 0. On the left hand side it will be 0. A sine beta into 0 plus b cos beta into 0. So 0 is equal to a, beta into 0 is 0. So this is sine 0 plus b cos beta into 0 is 0. Right? So what is the value of sine 0? So value of sine 0 is 0. Right? Sine 0 का value 0 है. So 0 is equal to beta, cos 0 value is 1. So therefore b is equal to 1. Right? So the value of b in the general solution, I got it as 1. Now I'll be using second boundary condition. What is second boundary condition? At x is equal to L, y will be once again equal to 0. So once again, therefore equation 3 becomes, what is your equation 3? This is your equation 3. Y का value क्या है? 0 है. So you put it as 0 is equal to a value, don't know, sine beta. What is the value of x? X value should be L. Right? Plus, what is the value of b? B value I have already found out, it is 1. So I'll write it as 1. Cos beta, x value is L. Right? So now let us go further and calculate. Here b value is 0. Right? Please don't commit such silly mistakes, because b into 1 is b, other side it is 0. So this is 0. B value is 0. So 0 multiplied by anything is 0. So therefore a sine beta into L. So 0 into anything is 0. So I'll just mark this as 0. ये 0 हो जाएगा. After that, you'll be getting this side as 0 as well. Now if we just compare this, we know that a is a constant in the solution. So a का value 0 नहीं होगा. Right? So what I am trying to tell here is, a is a constant in your solution. We know that it's a constant. It will be having some value. So whenever you are having a product equal to 0, then let us say it is of the form 3 into bracket x plus 4 is equal to 0. Right? 3 into bracket x plus 4 equal to 0. So what will you say? I'll say that x plus 4 is equal to 0. Right? So let me write it. Right? So this is not related to your derivation. It is just an example. Right? So example, what I'm trying to tell here is, suppose if you are having 3 into x plus 4 is equal to 0. So what you will write? Will you write 3 equal to 0? No, right? What you will be writing? You will be writing x plus 4 equal to 0. Same thing यहाँ पे हो रहा है. So here a is 3 and x plus 4 is your sine beta l. So a cannot be equal to 0, 3 cannot be equal to 0. So therefore sine beta l should be equal to 0. So therefore sine beta l should be equal to 0. So when sine beta l is equal to 0, what this implies? When sine theta will be 0, when sine theta will be 0, sine theta will be 0 for value of theta as 180 degrees, right? So whenever the value of theta is 180 degrees, sine 180 degree is 0 and sine 0 is also 0. If you are taking this as 0, then you will not be getting the value of beta, right? Now why I want beta, I'll tell you later, because it is my point of concern. You cannot take beta into L as 0, right? Sine beta L is equal to 0. You cannot take it as sine theta. So sine theta is equal to 0. So what is the value of theta? So theta value will be, theta value in this case it is beta into L, will be equal to pi, that is 180 degrees, right? Now squaring both sides, beta square L square is equal to pi square हो जाएगा, right? But what you had assumed previously, but beta square is equal to p divided by ei, right? I hope you remember previously I had assumed this. मैंने assume किया था कि beta square is p divided by ei. So now I'll back substitute that. So you put that value here. So what I'll be getting? Beta square value is p divided by e into I. L square जैसे की जैसे रख दो is equal to pi square. So therefore p is equal to pi square ei divided by L square. So this is nothing but PCR, which is crushing load, compressive load or crushing load. ऊपर से आप जैसे ही load apply करोगे, then the beam is getting crushed. So it is crushing load or compressive load, minimum compressive load that is required to cause buckling when both ends are hinged, right? So this is the end of derivation. So that's it. Let us meet in the next session for upcoming derivations. I request you people to go through this derivation thoroughly. Of course, there are some things which you need to remember, and for easier reproduction in your examinations, it is important that you remember those things, right? If you are not remembering such things up to after coming to a certain level, then understanding everything goes difficult, right? No doubt I'll be making you understand how I got that equation in the upcoming sessions, but for as of now you need to remember two things. That is the general solution, y is equal to a sin bx plus b cos beta x. That thing you need to remember, and you need to remember the deflection equation, right? So जैसे आप इतना याद रखोगे, then things will be easier, right? So take care, have a nice day.